So here's a little supplementary video to go with our week 2. This is about vectors, matrices, and arrays is really what our focus is for this week. And so what I want you to do is start off by that weekly introduction, which as you can see here, watch this video, and that explains the basics of vectors, matrices, and arrays. That should help you kind of understand what's already in the reading. So go through the reading, go through that video, and then as you start your assignment, there's a couple of pieces there that typically get students a little bit of trouble. So I thought I'd put a little supplementary video out there to kind of help you through some of those pieces. So let's get down to the actual exercise of what we're going to have to do here. Create a script that'll show vectors, matrices, and arrays. Do a predictive discrete value time series, so discrete values of 0 or 1, 1 or 2, etc. Perform a recode of data, generate a covariance matrix that is symmetric, and detect outliers within a stream of data. So many of the things that you're going to see in this assignment, there's pieces in the reading that just immediately you'll be able to see. They're showing you some of the things: the covariance matrix, the discrete predictor, and the detect of the outliers. All of those things are in the textbook. You can read those. You're able to use those, but the big key here is don't just copy what you see in the text. You want to copy what you have in the text, and then also if you're going to use those as opposed to writing your own, you're going to want to describe for each individual line. You'll want to go down and put the description in a comment of what that line is doing. That demonstrates that yes, you understand what that particular piece of code is going through. So a lot of these first couple of assignments, there's going to be some things that's going to be heavier on text, where you're going to have to actually explain what's happening inside of the code, as opposed to you're just writing this fresh. Now the reason for that is again, to help you kind of learn the language, but also as you do this, it kind of gets you used to the documentation process, etc. on that. So here are the two files which I use in that video right here, this introduction, week 2 and 2B. But what I'm going to switch over to here, right here, is here's a couple of things to drill a little bit deeper on it. So first of all, with that time predictor, right here is the function that you'll see printed inside of the textbook. Here is a discrete series. So a lot of questions have come in the past of what's a discrete series, like zeros and ones, just a string of zeros and ones. You can make these of various lengths. A little bit longer is probably better in this case. It'll be a little bit easier for you, less of a chance that you're going to have an issue with this. But within this function right here, what you would basically do is for each of these lines, you'd go in there and you'd leave a comment. So for example, right here, you'd put a pound sign, and you would just go ahead and write, why am I looking at storing the length of whatever I'm passing in as the first parameter? So the first parameter in this function is the discrete series, which I'm going to try to predict. The second parameter is going to be the element, which I want to take a look at, right? So out of this, that first string, you'll want to store the length of the string. That's what this first comment is about. So for this particular case, you would say, so then we know that, okay, the reason why you're storing that is because you're going to need to know what the total length of the string is. Because then you're going to do some mathematical operations to split it in half, etc. So each line, you would leave another comment, another comment, another comment. So then as I'm grading this, I go back through it, I'd be able to see that, yes, you understand what's actually happening in those pieces. Now what this is also going to do for future weeks, we talk about going back and using a time predictor. You don't have to write a time predictor from scratch. You're already going to have one in your toolbox that you'll be able to pull out and you'll be able to use in your code. So that's one piece, the discrete series and the time predictor. Those are two pieces that kind of throw students off a little bit. And if you're going to do it, here's one possible solution which you could do. And again, here's kind of the pseudocode of it, is determine the length, figure out what half is for that vector, create that placeholder, and then set the initial position to the placeholder, store the sum of the values in element 1 you want to predict. In this case, I'm trying to predict 4. If the sum is greater than a half mark, then set the predictor to 1, otherwise set it to 0. Create a for loop to iterate through that series. Again, setting the predictor to 1 or 0 is appropriate. Ensure you can have some safety checks in there so you don't end up with a negative number. If you do not put that in there, you can end up with a negative number depending on your string. And then if you're using this technique, you return the mean of the absolute value of the values returned. That absolute value will make sure you don't have a negative. So there's actually 2 safety checks built into the book's solution to this problem. Now, there are more elegant ways that you can write this, actually simpler ways that you can write this time predictor. So again, I'm going to leave that up to you as you work through your assignment. If you decide to use the one in the book, the big key is you have to cite that you use this from the book, and then each line you'll explain what's happening inside of that line so we can guarantee that we know that, yes, you understand what's going on for that. For the covariance matrix, a couple different ways you can solve for this too. There are libraries which can generate a covariance matrix for you. If you use that, great, fantastic. And actually, that's more impressive for some of the students that have gone out and done the research and pulled up the library. There's a library call that you could get basically a one statement, and you could make the call. It creates that covariance matrix for you. However, if you're going to do this manually, this is what the covariance matrix should look like. It's a symmetric covariance matrix. It has the row of 0.5 and an n of 5, so it's a 5 by 5 matrix. So this is, again, relatively straightforward, simple, if you understand the concept of matrices to generate something like this. Now, the only caution I'll make is do not just put 5 print statements out there printing that covariance matrix. That will not get any points. So it has to be a function to generate a covariance matrix, but it needs to be dynamic enough that we could add different variables. We could change things like row, and it wouldn't just be printing out those statements. That's absolutely not what that's designed to do. And the end result of this should be a matrix, a 5 by 5 matrix that could be used elsewhere in the program. So by simply printing that out, you're not going to get that matrix. Finally, the find outliers. So there's an almost endless number of ways that you can solve for this one. The book also uses this find OLs and then find OL. So it's using like a recursive function in order to call itself in order to come back and generate this. So this is one way. If you use this, same caveat that we've got up here with the time predictor, note where you've got it from, and also line by line tell me what each of those statements are doing. Why do you have that? Now, you can also take a look at the code that I've got here, and there may be a particular issue in the code. That's by design, so I put that in there just to make sure that students are actually going through it and they're not just copying down what they see on the screen here. So these are a couple of things that kind of throw students off. I'm going to caution you again just on the pieces of this. If you use the parts of the book, you got to put the comments on the back end of it like I've explained. Make sure you cite that you got it out of the book, the page, and the textbook that you got it out of. And then again, when in doubt, more comments is better. The other thing I'll say for your scripts that you'll turn in, it's good to also include like what week you're in. It's good to include what particular question you're trying to answer. Because if we just have nothing but statements and no kind of narrative going around it, I may not know that it's your work. I may see a piece of code and then think, wait a minute, this looks familiar to something else. So just put a little header on it. Just be easy. Put a little header on it. Hey, this is for week 2. Put in there that your name, so we have that. For each question, like if this is the question on the binary time predictor, put it in there. This is the binary time predictor. Then we go on to the next one to do for the covariance matrix. This is for the covariance matrix. So then I know this whole section of code is with the binary time predictor, and we'll be able to work off that. So hopefully this helps. Between watching those 2 videos, if you still have questions, it's going to be 7 o'clock Central Time, 8 o'clock Eastern Time. I'll open up the Collaborate room. I'll sit there and answer questions. If you want to talk about any of the questions you might have from the first week's assignment was fairly straightforward and simple. Once you get past the installing of the product, just doing a couple simple statements. If you had any questions from that, or if you have any issues with libraries or anything that you've installed as part of R, that's a good time just to kind of bring those forward. So we have an hour, we can sit down, we can walk through any of those items and help you kind of understand what's going on. Now, I will not just be walking through the solution for this week so that you can just copy and use that for your submission. I just wanted to make this additional supplementary video to kind of answer some of the questions with common for other students. So have a great week. If you have any questions, again, hit me up on the forums or send out an email and I'll respond to that. Have a good one. Thanks.